Hello, students, and welcome to the second video lesson on 5.2, going over examples 6 and 7 from the handout. All right, now this is actually the second video I'm recording over this because there was a technology glitch with the first one I did, and so I'm trying to hopefully this one goes better. Anyways, we're going to do a couple more problems here that are similar to ones you did in 5.1, where anytime you want to add or subtract fractions, we know we have to get a common denominator. Okay, so let's start with this one. Prove that tangent squared beta minus sine squared beta equals tangent squared beta times sine squared beta. All right, and they look very similar. One is subtraction, one's multiplication. How does that happen? Well, let's see. Okay, now it may not be obvious right away which side to start with, but we usually start with the left side unless it appears otherwise um, easier to do the other way. And also, you'll see here in a moment that you always want to, if you can, usually we start with adding or subtracting as opposed to multiplying, because once you get it's easier to get a common denominator combined to one fraction than to go backwards usually. Okay, so let's start with that. Tangent squared beta minus sine squared beta. All right, I don't see any identities I can use right away. I see squares, but there's no Pythagorean having to do with tangent and sine. So let's do this. Let's write tangent squared as sine squared beta over cosine squared beta minus sine squared beta. Okay, now we are subtracting fractions. So now I know what to do. I need to get a common denominator. This has the denominator cosine squared beta. So let me multiply this fraction by cosine squared beta over cosine squared beta. All right, now I can combine those into one single fraction with a common denominator of cosine squared beta. And then this becomes sine squared beta minus sine squared beta cosine squared beta. Okay, now you might think, well, wait a minute, can't I subtract sine squared minus sine squared? No, you cannot, right? Because this is a product, right? This sine squared is being multiplied by cosine squared beta. So these are not like terms. You cannot subtract them. But what you can do, both terms have a sine squared beta. So you can factor that out front. You can write this as sine squared beta times the quantity 1, because sine squared divided by sine squared is 1, right? And they take sine squared out of this term, and I'm left with cosine squared beta. So sine squared beta times the quantity 1 minus cosine squared beta, all over cosine squared beta. Now, this is often where it's helpful to look at the answer, see what you're supposed to get. I'm supposed to get tangent squared beta times sine squared beta. Well, what do I know? Sine squared over cosine squared is tangent squared, and 1 minus cosine squared, I could use a Pythagorean identity to show that 1 minus cosine squared is sine squared. We've used that one before. So here we go. So let's write that as sine squared beta over cosine squared beta, and then this 1 minus cosine squared beta becomes sine squared beta. Now, if you wanted to, you don't have to write this as break up the fraction. I could put that all over cosine squared beta. It's the same things, right? Because this is multiplying, right? This is multiplying now. So whether you write this as outside the fraction or in the numerator of the fraction, doesn't matter, okay? But then what happens? Sine squared beta over cosine squared beta. There's my tangent squared beta, and then times sine squared beta. And that was my answer. That's what I was supposed to show. Okay, so that was example 6. All right, one more. Example 7. I've got 1 over secant x minus 1 plus 1 over secant x plus 1 is 2 times cotangent x times cosecant x. All right, so as always, let's go to start with this fraction on the left. 1 over secant x minus 1 plus 1 over secant x plus 1. All right, I don't see any trig identities, okay, because that's secant minus 1, right? You cannot use a Pythagorean identity because there's no square, just secant minus 1, secant plus 1. I don't see any identities. So let's get a common denominator. All right, so I'm going to multiply the first fraction by secant x plus 1. I'm going to multiply the second fraction by secant x minus 1. Okay, so what do I have? My common denominator is secant x plus 1 times secant x minus 1. My numerator is secant x plus 1 times 1, which is secant x plus 1, plus secant x minus 1 times 1, which is secant x minus 1. All right, so simplify that. 1 minus 1 is 0. Secant x plus secant x is 2. Secant x, okay? Now my denominator, I have secant x plus 1 times secant x minus 1. Now sometimes we leave these in factored form because I want to cancel out one of the factors. But notice, what do I have here? I have the same two factors, one's plus and one has a minus. All right. In that case, you always want to multiply these out. You want to FOIL them. And the reason is you're going to end up with a difference of two squares. All right. Secant x times secant x is secant squared x. And the two middle terms will cancel, plus secant x minus secant x, and then 1 times -1 is -1. So I'm left with secant squared x minus 1. And that's one of my Pythagorean identities, right? That is tangent squared x. So I have 2 times secant x over tangent squared x. All right, now at this point you might stop and say, okay, that looks pretty good. But what do I want to get? I want to get 2 times cotangent x times cosecant x. All right, that doesn't really look like that. I've got the 2, but I don't know what else. Okay, so how do I go from here to here? Well, I don't see any other identities I can use right now, but remember a skill we use. If you're not sure what to do, write all your all your trig functions using tangent. Write all your trig functions using sine and cosine. I was getting ahead of myself there. So, so again, if you don't know what else to do, try writing all the trig functions using sine and cosine and see what happens. So, secant x we know is 1 over cosine x, and tangent is sine over cosine. So tangent squared x is sine squared x over cosine squared x. All right. Well, that looks kind of nasty there. I've got a fraction over a fraction. Well, we know what to do there. We can rewrite dividing by a fraction as multiplying by its reciprocal, right? We do that lots of times. And I'm running out of room, so let me go over here. I can 2 times 1 over cosine x is just 2 over cosine x. Instead of dividing by the denominator, let me multiply by the reciprocal times cosine squared x over sine squared x, okay? And now look what I have. I have cosine squared over cosine, so one of those cosines cancel out. I am left with 2 times the cosine of x over sine squared x. Okay, well, let's see. Does it help me? What do I want to get? I want to get 2 times cotangent x times cosecant x. Well, wait a minute here. Cosine times sine is cotangent, and then I have another sine in the denominator. Well, 1 over sine is cosecant. There we go. Let me just break this up. I'll put one of the sine x's under cosine x, and then the other sine x, let me just put under 1. And again, I can do that, right? Because these are all multiplied together. Because they're multiplied, not added. They're being multiplied. I can break up sine as sine times sine, and I can make another fraction if I want, right? Because 1 times cosine x is just cosine x. And then what am I left with? Cosine over sine is cotangent x. 1 over sine is cosecant x. And there I go. That's what I was supposed to show. Okay, so with these problems, just to be clear, with these problems, you must show all your steps to get your answer, right? Because it gives you the answer at the beginning, all right? Your work, the solution is your work, how you get there. So you can't just start with the answer and put equals this and magically make it appear, all right? You have to show all the steps, all the correct work to get your answer, all right? So you want to use a combination of trig identities and algebraic skills that you know. All right, so these were the last 2 examples. I'm going to give you some more homework problems to try, and then, as always, scan those and take a picture and share with me when you're done. I can check your work, and then after that, I've got a review sheet practicing more of these trig identities for you to practice with. Okay, bye-bye.